Parallel. A resistor, an inductor, and a capacitor are connected in parallel to a generator. Yes, this is parallel combination. R, L, C. In parallel, what is equal? Of course, potential difference. R, L, C will have the same potential difference because all they are parallel. Yani VC, VL, VR, even V of the generator are equal to each other. So then currents are different. I total, IR, IL, IC. We are going to use the potential difference as common factor according to potential difference, which is the same. We are going to define electric currents. So electric currents will be defined with respect to potential difference because the potential difference is the same for all components. For resistor, they are in phase, IR and V. But for coil, electric current is lags behind the potential difference, or potential difference leading. For capacitor, electric current leads the potential difference. For capacitor, again phasor. Two vectors opposite in direction. Which are they? IC and IL. What is the angle between these two vectors? What is the angle? Somebody tell me.
180.
Yes, it's a ministry exam question by the time. Yes, they asked this last year, I think. Which of the following two quantities have an angle 180 opposite in direction? IC and IL. IC all IR. IL and IR. So IC and IR. They are opposite in direction. Phase angle difference is 180. So we should subtract them to get, of course, the resultant. IC minus IL. And after that, we will use again the Pythagorean theorem to calculate the I total, this I total, which is the current supplied by the generator. So IR, IL, IC, but I total is calculated again by Pythagorean. IL, IR squared plus IC minus IL squared. Very similar to potential difference equation for RLC series. Only here is in RLC series VL minus VC yazmıştık. Burada IC minus IL. We are going to write that. Even if it's squared, it doesn't make difference. Negative, positive, because if you got the square and negative becomes positive. Even you can write this IL minus IC. It doesn't make difference here. But very similar to potential difference equation in series and electric current equation in parallel. Almost the same equations. And phase angle difference is the next step to calculate. We can get it. Again, we are going to use tangent theta. Tangent theta is opposite side over adjacent side. Opposite side is IC minus IL, but here is important. You shouldn't write IL minus IC. IC minus IL. Opposite of RLC series. RLC series was okay. I have a problem with the
Hocam, angle between IC and IL is 180.
Evet, evet. Şimdi kısa bir sorun çıktı sınavla ilgili. Şu an başka bir grup sınavı yapıyor siz geciktiniz ama bir şey düzenlemem lazım. Çünkü bir şey yanlış göndermişiz. Hemen onu halledeceğim. Yoksa Allah Allah nasıl olmuş bu? Yani test 2'yi 5 question olarak görüyorlarmış. Nasıl olduğunu anlamadım. Şimdi birkaç dakika onu halledeceğim. Sonra sizin sorularınızı alacağım ve devam edeceğiz. Tamam mı kızlar? Screen'imi görüyor musunuz?
Görmüyoruz hocam.
Görmeyin. İyi. Şimdi screen'de sorular var. Soruları görmeyin. Hayır, bir sorun yok. Evet, biraz bir şeyler varmış ama neyse artık sonra ilgilenirim. Yapacak bir şey yok. Sizinle devam edeceğim şimdi. Okay. All right, now let me go back to the screen sharing. Okay, Noah, what's your question?
Hocam dedim ki the angle between IC and IL is 180.
Yes, IC and IL, opposite vectors underneath, of course. IC and
Also,
IR, 90 degree. Don't forget them. They are changing questions every year. IC and IR, 90. IL and IR, 90. Look at here. Any more
Tamam
questions?
hocam.
Teacher, can you please quickly explain the other equation? 1 over z is equal to 1 over r squared.
Oh my God. This explanation, this proof is a little, but in fact, it's coming from the electric current equation, this one. From this equation, we got it. You can do it on your own. I total, because V's are equal, V over Z. IR is V over R. IC is V over XC. IL is V over XL. Because all V's simplify, you got 1 over Z is equal to root of 1 over R squared plus 1 over XL minus 1 over XC minus 1 over XL squared. Did you get it?
Yes, so teacher, the inverse of total impedance is I total. Like we can calculate I total by only if only we have total impedance.
Yes, I total, pardon, what about this you are talking about me?
Yes, yes. If we have total impedance, can we directly calculate I total without any other information?
Yes, yeah. If you know I total and V, you can get it Z directly without this one.
If we have Z, if we only have Z, the inverse of Z is equal to I total, so we can calculate I total only by
No,
Z.
inverse of Z is not I total. V over Z. V over Z is I total.
And what is 1 over Z?
1 over Z is nothing. It's just 1 over Z.
Okay.
This is an equation. Never change to this Z is equal to R squared plus. No, this is 1 over Z. First, you will get what 1 over Z is as a number. After that, you are going to flip it.
Teacher, that one is because the potential difference are equal, that's why we wrote 1.
Yes, potential difference are equal, they cancel, that's why it's 1 1 1 1 here.
Okay, thank you.
And there's a